Okay, we know how to use the command window and the workspace and the command history. Now let's do a more interesting calculation. Let's calculate the number of kilometers in a light year, which is the distance that a light beam will travel in a year. The speed of light is equal to 300,000 kilometers per second, which we can put into a variable like this. A few notes about this variable. First, the KPS is there in the name to remind me that the units are kilometers per second. You can't include units when you assign a value to a variable. The value is just a number. Second, note that it's okay to use the underscore as part of a name in MATLAB. And third, if you look at the workspace up here, you'll see that speed KPS is listed above X and Y. That's because variables are listed in alphabetical order, not in the order that they're created. Okay, back to the calculation. To compute a light year in kilometers, we multiply the speed by the number of seconds in a year. First, let's put the number of seconds in a year into a variable. I'm going to call it year sec. And that's equal to the number of days in a year, which is 365. We'll forget about leap year. Times, and we use the asterisk for times, the number of hours in a day, which is 24, times the number of minutes in an hour, which is 60, times the number of seconds in a minute, which is also 60. And there's the number of seconds in a year. So, to calculate the light year, let's do this. Light year, km, to remind me that this is kilometers, is equal to year sec times speed kps. And there you are. The answer, 9.4608e plus 12, might be a little mysterious. MATLAB has written the answer using scientific notation. The number after the letter E is the power of 10 that you multiply the part before the E by. So 9.4608e plus 12 is the same as 9.4608 times 1 trillion. Let's prove that by entering it the long way. So let's see here. 9.4608 times, see, a trillion is a 1 with 12 zeros, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There, sure enough, 9.4608e plus 12. Oh, and by the way, ANDS means answer. It's the variable that MATLAB creates to hold values that are typed in or calculated without being assigned to any other variable. And we can see it over here in the workspace. It's first because it starts with an A. Let's do one more calculation involving the speed of light. The distance from the Earth to the Sun is 149.6 times 10 to the 6 kilometers. Let's use our skill with scientific notation to assign that value to a variable. So Earth to Sun in kilometers is 150 times 10 to the 6th power. So how many minutes does it take light to get here from the Sun? That's what we want to calculate. First, let's calculate the number of seconds by dividing the distance in kilometers by the speed in kilometers per second, like this. There, it looks like it takes 500 seconds. And then we convert that to minutes by dividing by 60. .3333 minutes. Okay, we've got a lot of variables in our workspace. If we need to stop working and close MATLAB, it'd be a shame to lose them. You know, like if it's time to break for lunch or for dinner or for breakfast or whenever you do MATLAB. No problem. We can save them for when we come back later. We save them in a file simply by giving the command save, like this. There, it's all saved. And there's a message telling us where it was saved. What happened was MATLAB has copied everything in the workspace into a file called matlab.mat, and you can see it over here on the left. It just showed up. This file is called, imaginatively enough, a mat file. When we restart MATLAB, we can get all our variables back by copying them from that mat file into the workspace with a command called load. Let's prove it. First, let's clear out the workspace with the clear command. It's all gone. And just to make sure that we're not pulling some kind of trick because the assignment statements are in the command window, I'm going to clear that with the CLC command. I've used that once before. There, it's all clear. And if we try to check the value of the last variable we created, we'll get a red reprimand. Let's do that. Let's make a new variable called mini by assigning a value to it. Now we have just mini in the workspace. But we can get our other variables back with the load command. And there they all are. And note that mini is still there. Okay, let's take a minute or two to talk about MATLAB's rules for variable names. First of all, you've noticed that we can use underscore. We talked about that, in fact. And you can use uppercase. Mini's a great example. And speaking of uppercase, the uppercase can go anywhere. Let's make Mickey equal 9. And now I'm going to make a Mickey with a capital C in the middle. And I'll make him equal to 5. If you look over here in the workspace, you'll see these are two separate variables. The fact that this is a capital C makes this variable different from the one with the name that has only a lowercase c there. You can also have digits in the name. Let's try x45 equals 66, 7. And, well, but you can't have them just anywhere. There. You see red, so there's something wrong with that. And you can't have other characters. I mean, you can't have any characters other than letters. So if we did this, notice that's already red. Red's never good. So we'll try $x. That's no good. $x equals 7. That doesn't work. And you can't start with an underscore. Already, there you go. You have to stick to the rules that the characters in a variable name can only be letters, underscores, or digits, and you have to start with a letter. And one last rule. The length is controlled. You can't have more than 63 characters. So if you're planning on having a variable that had 64 or more characters, I got bad news for you. You can't do it. But I have never come close to that. Maybe I've used 25 characters, but I doubt it. Okay, this desktop has gotten very cluttered. Let's clear the screen. The CLC, we've used that before. By the way, CLC stands for Clear Command Window. The workspace is cluttered too. Let's get rid of that. Now, much better. And you know you can clear the history too. You just come down here and hit Clear Command History. It says, are you sure? There. Now everything's nice and clear. And while we're on the subject of clutter, let's give a command. There, I'm imagining that I'm supposed to set the absolute value of 0 in centigrade, which I've done. and the value shows up here in the workspace. It also shows up here on the screen. MATLAB echoes the value that was assigned to the variable. Well, a lot of time we don't want to see that. We just want to assign it and have nothing happen. Let's do another assignment. What I'm doing is setting absolute zero in Fahrenheit by using the formula. But this time I put a semicolon on the end. When I hit return, nothing's echoed back. But over here in the workspace, something actually happened. Just to emphasize that, let's do one more. Sticking with the temperature theme, I'm using paper ignition Fahrenheit equals 451 there. Again, the assignment took place, but there was not this echo over here cluttering up the screen. There's also another use for the semicolon. It'll allow you to put multiple commands on one line. Let me show you that. So I write x equals 42, then a semicolon, and then I just keep on typing and note enter. Now I'm going to hit the enter. You look over at the right, the command x equals 42 is executed. So is the command y equals 87. There's no echo. We got these semicolons, but also we separated the first command from the second command with the semicolon on the same line. You can put as many statements as you want on a line as long as you separate them with semicolons. Or you can substitute a comma for that purpose. Let's watch this. I'm going to put a comma here instead of a semicolon. Leave this part the same. We were able to do two different commands again, the same two commands. The only difference is this time we got the echo. So the semicolon's doing two things here. One, it's ending this command and allowing us to begin another one on the same line. And secondly, it's silencing MATLAB's echo. Here the comma ends one command and allows us to begin a second command on the same line, but it allows the echo. And not only can you have multiple commands on one line, you can have one command on multiple lines. Let me show you what I'm talking about. Let's use a really long variable name here. For some reason I just have these long variable names in my mind. So we've gotten to this point, and I want to multiply that times the other variable called another long one, but there just doesn't seem to be room here. So what I'm going to do is hit 3 dots. I don't know if you can see this. Let me magnify this a little bit. The dots turn blue. They're special. Those 3 dots, 3 periods, 3 full stops, whatever you like to call them, allows me to continue this one statement on the next line. So I'm going to hit enter. I'm down here. The blinker is still blinking. Nothing has happened. No error. No echo. And I'm going to type the rest of my command. There. It's as if we typed this whole thing from here, not counting these 3 dots, all the way to here on one line. And you can continue as many lines as you want if you keep using those 3 dots on each line, except of course the last one.